Welcome friends to this video. In the last video we talked about how to find out the transfer function of a closed loop system. In this video we'll be talking about the basics of a few system structures and types of systems, and then we'll be plotting some pole zero maps, and we'll be moving into depth with how we need the pole zero map and what a pole zero map can predict about the system. So let us start with a basic system structure. A system structure, this whole thing is what we call as the system. The system will obviously have an input and it will have an output obviously. As we talked about in the closed loop system, the system has a feedback which goes into a type of comparator and we find out the error signal. This error signal is moved into a device which is known as the controller. This controller regulates how much control we need upon the error signal such that it can reduce the error completely, such that the plant can perform in its optimum level. The plant obviously has some disturbance, that is why what input we are giving directly the output is not coming because of these disturbances and many other parameters. So this is what is the whole control system. This is a closed loop system where a feedback is given. This is the controller and this is the plant, which is the main thing. So as we can see that a system can have one input or it can have multiple inputs also, and it can have one output or multiple output also. So based on this, systems may be classified into four types: SISO system, single input single output system; CMOS system, single input multiple output system; MISO system, multiple input single output system; or MIMO system, multiple input multiple output system. So these are how a system can be classified based on inputs and outputs. Based on behavior, system can be classified majorly into two types. One is the stochastic system and one is the deterministic system. Stochastic system and the other is deterministic system. Now what is a stochastic system? A stochastic system is a system in which we cannot predict the behavior of the system. That is, the system is too random to disturbances or any other thing. That is a random system. Whereas a deterministic system is a system in which we can predict that how the system will respond. That is, it is like a system whose behavior is predictable. So we can know that how it will behave to a particular type of input. So this is the system structure basically. Now we'll move on to the PZ map, that is a pole zero map of a system. Now first of all we need to know what a pole and what a zero is. Now we basically know what a transfer function is, right? A transfer function is the ratio of the output of the system to the input of the system in Laplace or S domain, right? So the transfer function can be basically written like this, that it is S minus Z1 into S minus Z2 into ... S minus Zn by S to the power L into S minus P1 into S minus P2. We explain to you what this is, this whole thing is. Now any transfer function has a numerator part and a denominator part, right? So the values on the numerators, that is the values of s's on the numerator, are known as zeros. We'll talk about it with an example and it'll be clear totally. And the values of zeros in the denominator are known as poles. Okay. Now for a transfer function, definitely the number of poles should be greater than the number of zeros, because if it is not, then it is not a valid transfer function. You need to know that number of poles should be greater than equal to number of zeros, right? So let's start with this thing. Now, as we can see that the transfer function, I have written this s to the power l separately and this whole thing. Okay. The maximum power of s, that is if we multiply this whole thing, we'll get a maximum power of s. The maximum power of s is known as the order of the system. Okay. And the powers of s only on s is known as the type of the system. Suppose we make a system like this, that is s plus 2 by s into s plus 3. This is a system, this is a transfer function of the system. So what is the maximum power of s in the denominator? It is 2. So this is a order 2 system. What is the type of the system? Yes, as we can see that the power of s is only 1, so the type of the system is type 1. Based on this, we can have a type 0 system, type 1, type 2, and so on, and order also can increase. In our basic curriculum, we have till order 3 or order 4 type of system, and type 0, type 1, type 2, type 3 systems, etc. Okay, now we need to know how to do a pole 0 plot. So now we know that this whole thing is known as 0, these are known as poles. We need to plot these in a plane. We plot this in a plane which is called the real and the imaginary plane. Okay, this plane is usually known as the PZ plane. There is the real axis and this is the imaginary. Okay, so how do we plot? We can see that this is s plus 2. What we have to do is we have to equate every single of these factors to 0. So s plus 2, if it is equal to 0, if it is s plus 2 equals 0, then we can find that s equals to minus 2. So if we mark it as minus 1, minus 2, minus 3, so we can find that this 0 would be located at a point minus 2 on the real axis, because there is no imaginary part out here. Zeros are designated with this, a dot and this thing. This is how a 0 is designated, and a pole is designated by this. Okay, this is how a pole is designated. So 0, so we'll just give a circle out here. Okay, where do we have pole? S equal to 0, because s, this factor, is equated to 0, so s equal to 0, we have a pole. Where else do we have pole? S plus 3 equal to 0 or s equal to minus 3, we have a pole. So we give here as a pole. So this is how we have to plot the pole 0 map of any system. We can solve 1 or 2 more examples in the corresponding videos and it'll be more clear how to solve it. Thank you for watching.